The existence of a formal language for representing information and the existence of a corresponding set of mechanical manipulation rules have an important consequence, namely the possibility of automated reasoning using digital computers. The idea is simple. We use our formal representation to encode the premises of a problem as data structures in a computer, and we program the computer to apply our mechanical rules in a systematic way. The rules are applied until the desired conclusion is attained, or until it's determined that the desired conclusion cannot be attained. Unfortunately, in some cases, this determination cannot be made and the procedure never halts. However, in many practical cases it works, and the idea is basically sound. Today, the prospect of automated reasoning has moved from the realm of possibilities to that of practicality, with the creation of logic technology in the form of 1. Standard logical languages, 2. Automated reasoning systems, and 3. The development of knowledge bases, definitions, physical laws, artificial laws, and so forth. The emergence of this technology has led to its application in a wide variety of areas. To begin with, there are obvious applications in mathematics. Automated reasoning programs can be used to check proofs, and in some cases can produce proofs by themselves, or at least portions of those proofs. For example, given the axioms of group theory, which assume the existence of a right inverse for the group's operator, it's a simple matter for an automated theorem proving system to prove that the inverse is also a left inverse. Over the years, automated reasoning methods have been used to prove or verify proofs of many fundamental theorems in mathematics. There are libraries of problems to use in testing theorem provers, such as the TP library. And there are annual competitions pitting theorem provers against each other, most notably the competition at the annual conference on automated deduction. Engineers can use the language of logic to write specifications for their products and to encode their designs. Automated reasoning tools can be used to simulate those designs and in some cases validate that the designs meet their specifications. Such tools can also be used to diagnose failures and to develop testing programs. By conceptualizing database tables as sets of simple sentences, we can use logic in support of database systems. For example, the language of logic can be used to define virtual views of data in terms of explicitly stored tables, such as this definition of grandparent in terms of parent. And it can be used to encode constraints on databases, such as this constraint that people cannot be their own parents, or this second constraint that people cannot be the parents of their parents. Automated reasoning techniques can be used to compute new tables and to detect problems and to optimize queries. Logical spreadsheets generalize traditional spreadsheets to include logical constraints as well as traditional arithmetic formulas. Examples of such constraints abound. For example, in scheduling applications, we might have timing constraints or restrictions on who can reserve which rooms. In the domain of travel reservations, we can have constraints on adults and infants. In academic program sheets, we might have constraints on how many courses of varying types that the students must take. And there are applications in law and business. The language of logic can be used to encode regulations and business rules. For example, as shown here, we can define the concept of an office mate, and we can use that concept in expressing a business rule about office assignments. Given such rules, automated reasoning techniques can be used to analyze such regulations for consistency and overlap and so forth. This exercise allows you to try out a very simple logical spreadsheet.